This is section 9.2a, arithmetic sequences. A sequence is arithmetic if the differences between consecutive terms are the same. And again, this becomes clear when we see specific examples. So this is an example of a sequence, and we can see that the difference between consecutive terms is the same. It's all 5. And so that's called the common difference. And therefore this is an arithmetic sequence. So it's any sequence in which the jump from one term to the next, or the difference between one term and the next, is the same for each term. So here 4 jumps to 9, so that's a difference of 5. 9 to 14 is a difference of 5. 14 to 19, 5, 19, 24, 5, etc. So sequences that follow that pattern are called arithmetic. The formula for the nth term of this sequence is a sub n equals 5n minus 1. Now we're going to learn how to find the formula for the nth term, but the reason I'm putting it up now is just to get you familiar with the way this is expressed. This expression at the very bottom of the screen, a sub n equals 5n minus 1, is called the formula for the nth term of the sequence. And that just, it's a general equation that for any n you plug in will give you the right value of the term. Alright, so let's see how this works, 5n minus 1 for this sequence here. Well, remember that the value of a term is not the same as the number or order of the term. Okay, so here for 4, where the arrow is circling, for 4, the value of the term is 4, but the value of n is 1. n equals 1 because it's the first term. Here, value of the term is 9, value of n is 2. Here, value of term is 14, n 3, value of term 19, n 4, value of term 24, and 5. Okay, that's just a review of what we've already learned, that the value of a term is not the same as the number or order of the term. So let's see or make sure that this formula for the nth term works for this arithmetic sequence. Alright, well, when n equals 1, as is the case with this term, n equals 1, if I plug in 1 for n, I get 5 times 1 is 5 minus 1, and that's 4. And as I can see, 4 is the value of the first term. How about the second term? For the second term, n equals 2. Second term, n equals 2. Alright, so I plug in 2 for n down here in the formula for the nth term, and I see that 5 times 2 equals 10 minus 1 is 9, and that is the correct value of the second term. And you can continue to do that test for all of these terms, and you'll see that it works. So again, we're going to learn how to find that formula for the nth term, but for now I just want you to be familiar with the format, and what they're called, and the way things are written. Let's look at this sequence. Alright, if we evaluate the differences, we see that there is a common difference. And the common difference is negative 5. So we know this is an arithmetic sequence because there's a common difference. Now, the question is, can you find the formula for the nth term of this sequence? Now, I know that I haven't taught you how to do this yet, but sometimes it's good to try to do something on your own to figure it out, and then the explanation makes more sense. So see if you can do this on your own. You're going to have to, think about it. You're going to have to ask yourself the question, what do I have to do to each n to get the value of the term? That's the question you have to ask yourself. Like, for example, here n is 1, value of the term is 2. Here n is 2, value of the term is negative 3. Here n is 3, value of the term is negative 5. Alright, your answer, of course, is going to have something to do with the common difference, negative 5. But I want you to try to figure this out on your own. What do you have to do to each n in order to get the value of the desired term? So pause the video, try to figure it out. Don't spend too long on it. but do try to think about it, and then resume when you're stuck or when you have what you think is the right answer. This is the answer. A sub n equals negative 5n plus 7. All right, well, if I look at this, I can see some familiar things. The negative 5 here, I simply get from the common difference, which is negative 5. So I know that for each n, 1, 2, 3, 4, 5, 6, 7, etc., for each n, I'm going to have to multiply it by negative 5 because there's a jump of negative 5 each time. All right, but where does this plus 7 come from? Well, plus 7 is the adjustment we have to make at each n in order to get the desired term. Okay, again, I'm going to lay this all out, but this was just an exercise in trying to think about it. And hopefully you at least made some progress and were able to come up with something. If you weren't, don't worry about it. Sequences and series are often hard for students, even in college, so it's not a reason to be concerned. But pay attention and work hard for the rest of this chapter, because it is kind of a hard chapter, and a lot of the concepts are difficult for students. All right, let's look at this example. Find the first 5 terms of the sequence and determine if it is arithmetic. So this is the sequence. A sub n equals 1 plus n minus 1 times 4. And when you just plug in different n's, you're going to see the first 5 terms of the sequence. And the first 5 terms are 1, 5, 9, 13, 17, and the common difference is 4. All right, so that's an easy one, right? For this example, all you do is plug in numbers, find the 5 terms they ask you for, and then see if there's the pattern of the common difference. And in this case, there is. And therefore, this sequence is arithmetic. Now let's learn about finding the formula for the nth term of an arithmetic sequence. Okay, these formulas have the form a sub n equals dn plus c. And if you look back at the previous screens, if you look back at your notes from the previous screens, you'll see that in each case when we gave a formula for the nth term, it had this pattern. It had this pattern of dn, the common difference, times n, plus some constant c. And the way to find these is d is the common difference. We know how to get that. You just find what the jump is from one term to the next. And then c is the adjustment constant, and c is always found just by by the difference a1 minus d. Now let's see this in action, and it'll make more sense. Let's look at this example sequence. All right, 2, 8, 14, 20, 26. All right, well, it's obvious that a sub 1 is 2. A sub 1 just means your first term, and your first term in the sequence is 2. Okay, so that's pretty easy. Now, let's look at the difference. Well, let's see, if 8 minus 2 is 6, and 14 minus 8 is 6, and 20 minus 14 is 6, and 26 minus 26, then the common difference is 6. So we found A1, we found D. And now C. C is how you have to adjust to get the value of each term. So C equals 2 minus 6. Why? Because A1 is 2, D is 6, 2 minus 6 is negative 4. And the formula for the nth term of this sequence is 6n minus 4. If we use this formula 6n minus 4 and test it for each term of this sequence, we're going to see that it comes out right. So let's see, when n equals 1, so for this term, n equals 1 because we're talking about the first term. Plugging in 1 for n gives me 6 times 1, and that's 6 minus 4 equals 2, and I get 2. Let's plug in n equals 2. Plugging in n equals 2 here gives me 6 times 2 is 12 minus 4, and that's 8, and so on. All right, so this is the way to find the formula for the nth term. Of course, you could just have figured this out because really all you're doing is adjusting once you have the common difference and you multiply it by the number of terms, you just adjust by adding c. And in this case, of course, c is negative, but it doesn't matter. You have a constant, whether it's positive or negative. And you'll end up with the value of each term, the correct value of each term. Okay, so quick recap. When you're asked to find the formula for the nth term, it's going to have this format, a sub n equals dn plus c. And then d you get easily from looking at what the differences are. And then c, you simply use this equation, c equals a sub 1 minus d, and that will give you the correct c. Another example, find the formula for the nth term of an arithmetic sequence whose common difference is 4 and whose first term is 15. Find the first 5 terms of the sequence. Alright, so you should be able to do this on your own. Again, you got to think about it. You can use what you learned on the last screen. But pause and try to answer this question on your own and then resume when you have an answer. Okay, so walking you through the solution, we know that we want this formula, a sub n equals dn plus c, and of course we can fill in 4 for d. And c is just a1 minus d. I know the first term is 15, so 15 minus 4 equals 11, and therefore my formula is 4n plus 11. So a sub n equals 4n plus 11 is my formula, and I just got that by plugging in the d, which came from the problem, common difference is 4, and the c, which came from the equation we learned on the last screen, a1 minus d equals c, and that is 15 minus 4 equals 11, because the first term was given to us. Okay, so hopefully you got that on your own. Now, finding the first 5 terms of the sequence is really just a matter of plugging in numbers. Numbers 1, 2, 3, 4, 5 for n. And the first 5 terms are a1 equals 15, right? So I get 15, and then I know the common difference is 4, so I can just keep adding 4, or I can simply plug in different values of n into the formula for a sub n, and I will get these same 5 answers, these same 5 terms. Alright, so once you have the formula, finding terms is easy. Alright, now here's a harder example. Find the formula for the nth term of an arithmetic sequence whose 4th term is 21 and whose 13th term is 66. Find the first 5 terms of the sequence. Again, this is a good chance to think about it, to challenge yourself. Challenging yourself helps in math. It helps with really every subject. It helps in life in general. And even on a practical level, the SATs or the AP exams. Obviously we don't study in school just because of tests, but most students want to do well on the SATs and the AP exams, and those tests are designed to make you think, to throw things at you that maybe you weren't taught exactly how to do, but you need to figure them out. So pause the video, try to figure this out. I know it's a hard one. Don't spend too long on it if you get stuck, and then resume when you have an answer or when you need help. Okay, so let's walk through this one. There's a long way to do this, and I'm going to show you the long way first, because the long way always works, and it's easier to understand at first. So doing this the long way, I simply write out what I know. Okay, the problem tells me that the 4th term is 21. So see how I have 21 here? Well, 21 is my 4th term. I don't know what the 1st, 2nd, and 3rd are yet, but see how A5 follows from 21. So 21 is my A4, my 4th term. And then A5, A6, A7, A8, A9, A10, A11, A12. And then 66 is my A13 because the problem tells me that the 13th term is 66. So A sub 13 is 66. All I've done in this line is just fill in what I know. I filled in the things that I can get straight from the text of the problem. Okay, well now if this is an arithmetic sequence, which I already know because the problem says so, I know there's going to be a common difference. And so how to find the common difference? Well, I know that from one term to the next, there's going to be a jump of d. So 21 plus d equals a sub 5. A sub 5 plus d equals a sub 6. A sub 6 plus d equals a sub 7. A sub 7 plus d equals a sub 8. A sub 8 plus d equals a sub 9, and so on. And then a sub 12 plus d is 66. So this is just writing it all out. I know there's a common difference, so I can write all these plus d's down there. And then I can come up with this equation, which is simply that a sub 13 equals a4 plus 9d. All right, where do we get this? All right, a sub 13 is 66, which the problem tells me. A sub 4 is 21, which the problem tells me. And where does this 9 come from? This 9 comes from the fact that there are 9 jumps from term 21, or the fourth term, to term 66, or the 13th term. There are 9 jumps. And let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, there are 9 jumps. And then I can just solve for d, because I know that a sub 13 is 66, a sub 4 is 21, plus 9d, and then just using algebra 1, I can find that, that d is 5. Okay, so that's the long way to do it. Of course, you could have also done it the shorter way, which is just, 66 minus 21. We see that this is 66 and that's 21. Well, I know then 66 minus 21 is how much it changes over the course of 9 terms. And then I can just go straight to this equation, 66 equals 21 plus 9d. Why? Because 13 minus 4 equals 9. So I don't care whether you do it the long way or the short way. If there's a big difference in terms, like let's say they gave you the 4th term and they gave you the 600th term, well, doing it the long way will take you forever. But the short way is easy, because you just look at these subscripts. See, this is 13 and this is 4, and 13 minus 4 is 9, and that's how you know what to plug in here. Okay, so you can do it the long way or the short way, but sometimes the short way is going to be a lot more practical. In any case, the main thing to understand from this problem is that you have the common difference, and that is going to affect, it's the jump. It determines the jump from each term to the next. So now we need to find a formula for the nth term of this arithmetic sequence. So I know that I want a sub n equals dn plus c. I've got to use that format. And I can fill in 5 for d because I know the common difference is 5. And now I just need to figure out c. Now to figure out c, we know that c is simply a1 minus d. But I need to figure out a1 first, don't I? Okay, so to figure out a1, it's simple. There are again 2 ways. One's kind of longer, one's kind of shorter. If we want to do it the somewhat longer way, I can just fill in 21. I know that that's a4, and then I go backwards. All right, if that's a sub 4, well, the 3rd term is 16, a sub 3, because that would be subtracting the common difference since I'm going backwards. And then the 2nd term must be 11, because that's 16 minus 5 is 11. And then the 1st term must be 6. Okay, I just go backwards from the 4th term to the 1st, and using the common difference I find that it's 6. So a1 equals 6. The short way to do this is just to set up the equation 21 minus 3d equals a sub 1. And again, I get this 3 because I know that there are 3 jumps from the fourth term to the first, since 4 minus 1 is 3. And I can see that visually here. You know, a4 to a3, that's 1 jump. So follow the arrow, I get 1 jump, 2 jumps, 3 jumps. Okay, so 21 minus 3d, that's where I get the 3. And I know that has to equal a1. And then using algebra 1, when I plug in 5 for d, I simply get a1 equals 6. Okay, because I know that d is 5. So 21 minus 3 times 5 is 21 minus 15, and that equals a sub 1, which is 6. Alright, so now we have a sub 1, and that means that we can find c using our equation that we already learned, which is c equals a1 minus d. I know that a1 is 6, I know that d is 5, and 6 minus 5 is 1. So I can now write the formula for the nth term of this sequence. And the formula for the nth term is a sub n equals 5n plus 1. Now, recall, I'm going to go back for a second. Recall that the problem asked us not only for the formula for the nth term, but it asked us also for the first 5 terms of the sequence. And when you have the formula, finding the first 5 terms is pretty simple. It's just plugging in numbers. So doing that, now that I have the formula a sub n equals 5n plus 1, I just plug in different values of n, 1 through 5, and I get 6, 11, 16, 21, 26. Let's test this out. Plugging in 1 for n, 5 times 1 is 5, plus 1 is 6, 6. Plugging in 2 for n, 5 times 2 is 10, plus 1 is 11, you get 11. 5 times 3 is 15, plus 1 is 16. 5 times 4 is 20, plus 1 is 21. 5 times 5 is 25, plus 1 is 26. And it checks out. The classwork, page 659, please write these numbers down, and we'll see you in class.